So now, in this video, we are just going to look at the basics of a resistor right there. How much current is going to flow through it based on the voltage across it. We're going to use the simplest example of 1 volt across it. And remember, when things are in series, so every part of the circuit here is going to have the same amount of current flowing through it. In this particular circuit, we have a voltage source, and that's the negative side of the voltage source, positive side, and it's across a resistor. The current's going to go through the voltage source as well as the resistor is all going to be the same. So that's going to be in amps right there. It's pretty simple if it's only 1 volt. So you take the voltage that's across the resistor divided by its resistance. So if it's 100 ohms, that's 0.01 amps. That's the same as 10 milliamps right there. And the resistor is not going to get very warm. So most resistors are rated for a quarter watt, which is 0.25 watts, but you should still keep that below 0.125 watts, halfway below that. When it comes to wattage, general rule is whatever the maximum wattage is, try to stay below half that. And there you can see, that's, less than a tenth of 0.125. So this isn't going to get hot at all. And then we can, double the resistance. 220 ohms is a lot more common value than 200 ohm resistor. And so in any case, we're going to use that. And this is rounded off here, but it's basically 0.045 amps. So it's about twice the resistance, a little bit more than twice. And there you can see it is a little less than half of the current that's going to flow through the circuit. And again, it's going to get about half as hot because the voltage is the same as when we used the 100 ohm example, but we're going to get about half of the current. So it'll be about half the wattage. That's how much heat the resistor will produce and have to dissipate. So if you get to where you don't like how much a resistor has to dissipate, you can use a bigger resistor which can dissipate more heat more easily, higher wattage resistor. Now we have 1 volt divided by 470 ohms. So if we put 470 ohms there, we're going to have about half of what we did there, about a fourth of what we did there, probably about a fifth actually in this case, because you're getting about 5 times the resistance, so about 1/5 the current as 100 ohms right there. And again, with the wattage, it's very easy with 1 volt right there. We'll have about a fifth of the wattage that we had there, but there's only about a fifth of the current going through. So that works when you have 1 volt. When you do 2 volts, then you would have twice the current flowing through it. Twice the voltage times twice the current would be 4 times the wattage. Keep that in mind. Wattage goes up faster than current. If the voltage is going up, it's very easy to overheat components. Be aware of that. We're not going to go with that in details in this video. Just something to be important to be aware of. And then we have 1 volt divided by 1,000 ohms. This comes up more often than the 1 volt divided by 100 ohms. For every volt across 1,000 ohms, you're going to get 1 milliamp of current, which is the same as 0.001 amp. And again, with 1 volt, it makes the wattage calculation easy. It's the same as the current. Now, if we had 2 volts, that would be 0.002 amps, which would be 0.004 watts. So the current would double because the voltage doubled, which would lead to the wattage being 4 times higher. So again, remember, as voltage goes up, components start overheating more easily, especially the resistive components. There's other components that keep a certain voltage across them. The resistor will take the rest of the voltage. And so usually when it comes to wattage, you're mostly worried about a resistor somewhere overheating if you are not careful. That's just something to be aware of. So in any case, these are just some simple examples I wanted to put together. I'm going to be working on other simple examples. When you understand this simple stuff, you understand it more easily in more complex circuits. There's a lot of complex circuits where you know, you're interested in what it's going to do because it's complex. It does something interesting, but you still have resistors in there that you need to prevent from overheating, and you gotta be aware of how much current is flowing through them. So even though this is not exciting, it is important. So hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help a lot. I'll see you in the next video.